In this video, I'm going to show you how to divide polynomials using long division. Here we've got a polynomial 2x squared plus 9x plus 6, which we'll call the dividend, and we want to divide that by another polynomial, x plus 2, which we call the divisor. This idea of dividend divided by divisor should sound pretty familiar from arithmetic long division. And to do polynomial long division, we use a really similar process. We start off by setting up the long division diagram, and then we put the divisor on the outside and the dividend on the inside. In arithmetic long division, we ask how many times does the divisor go into the first few digits of the dividend. And in polynomial long division, it's a really similar idea, except this time we ask how many times does the highest degree term of the divisor go into the highest degree term of the dividend. I'm going to underline the highest degree terms here. The highest degree term of the divisor is just x, and the highest degree term of the dividend, that's 2x squared. So we ask how many times does x go into 2x squared? And to figure that out, we can just divide. We can divide 2x squared divided by x. That'll tell us how many times x goes into 2x squared. And the result of that is just 2x. So this result we put up in the quotient above the bar here, 2x, and we'll line that up with the 9x in the x column. And now we just need to figure out what the leftover is when we subtract x plus 2 times 2x from this dividend term. So let's figure out what that is here. Let's take x plus 2 and let's multiply it by 2x. And our result, 2x times x, that's just 2x squared, and then 2x times 2, that's 4x. So it's 2x squared plus 4x. We'll write that underneath our dividend, 2x squared plus 4x, and then we subtract. So here we have 2x squared minus 2x squared, so these leading terms cancel out, and then we have 9x minus 4x, so that makes 5x. So just to recap what we've done so far, we've asked how many times does x plus 2 go into 2x squared plus 9x plus 6? Well, to start off, x goes into 2x squared 2x times. We found that by dividing 2x squared divided by x. That's how we got the 2x. And then we have to subtract off the result and see how much is left over still. So we got 2x squared plus 4x for our result. We subtracted that, and the leading terms, the x squared terms here, canceled out. And that's something that we want to make sure happens every time. The leading term should cancel out, and as long as we do the division here, 2x squared divided by x correctly, then these leading terms should cancel out. Now we just need to bring down this 6 here and repeat the process again. So just like arithmetic long division, we're bringing down another number and repeating the same process one more time. So this time we ask how many times does x go into 5x here? And we can figure that out the same way. We do 5x divided by x, and our result is just 5. So x plus 2 goes into 5x plus 6 5 times. So we write the 5 up here in the quotient, and we go ahead and multiply x plus 2 by 5. X plus 2 times 5 is just 5x plus 10, and we write that result underneath here, 5x plus 10. And then we just subtract, see how much is left still. So now 5x minus 5x, that cancels out, that's 0, and that's good because it tells us that this 5 that we put it in the quotient, that's correct. That causes the leading terms to cancel out. And then we've just got 6 minus 10 is negative 4. And now, since the degree of this remaining term is less than the degree of the divisor, this is just our remainder. We can't divide it anymore. That's just that's what we're left with. So remainder is negative 4. So now we're done with the algorithm part, but we still need to interpret our findings. Like what's our general takeaway from this? Remember that the dividend divided by the divisor is just equal to the quotient plus our remainder divided by our divisor. That's how it goes in arithmetic long division, and it goes the same way here. Let's go ahead and label our quotient and remainder up here. This is our quotient, and this is our remainder. So this is telling us that our original fraction, we'll write that down, 2x squared plus 9x plus 6 divided by our divisor, x plus 2. That problem, that division problem, this fraction 2x squared plus 9x plus 6 divided by x plus 2 is equal to our quotient, 2x plus 5, which we get from above here, and then plus our remainder. Our remainder is -4, so plus -4 over our divisor. And our divisor was just x plus 2. So this here is our conclusion of our long division process. This is our result right here. This is our answer. 2x squared plus 9x plus 6 divided by x plus 2 is 2x plus 5 plus -4 over x plus 2. That's our result. And we can check that result just to make sure it's right. These two expressions should be equivalent, and we can check it by just multiplying both sides by x plus 2. So we'll write down check over here, because this isn't something that we absolutely need to do, but we can do so to be sure of our answer, to be sure that it's right. If we multiply both sides by x plus 2, on the left-hand side, well, the x plus 2 will just cancel with the existing x plus 2, and we'll just get 2x squared plus 9x plus 6, and that is equal to the left-hand side, 2x plus 5 plus our remainder plus -4 over x plus 2 times x plus 2. So we'll put that in blue to match up the colors. And if we multiply this out, it should yield the same result as the left-hand side. So let's go ahead and do that. So x plus 2 times 2x plus 5, we'll write that over here. So 2x plus 5 times x plus 2, and then we've also got a plus 4 over x plus 2 times x plus 2. And if we multiply this out, we get, well, 2x times x, that's 2x squared. Then 2x times 2, that's 4x. Then 5 times x, so just 5x. Then 5 times 2, which is 10. And then here the x plus 2 cancels with the x plus 2 in the denominator, so just plus 4. Oh, this should be a -4. So -4. Okay, and then we can group up all the terms here. So that's 2x squared plus 9x. 10 minus 4 is your 6. So that matches up well. Yeah, so we can be sure that it's right. Here's another example. We want to divide 7 plus 2x cubed minus x minus 11x squared by 1 minus 2x squared. And so this is a very similar problem to the one we did before, but there is one thing that we have to do before we get into the whole long division. And that one thing that we have to do is we have to order the dividend and the divisor here. Right now, all the terms are out of order. Our constant comes first, then we've got an x cubed term, then an x term. It should really be the x cubed term, then the x squared term, then the x term, and then the constant term. If we want to do long division and we want to stay organized and match up all our degrees into columns, we need to order it beforehand. So let's do that first. Let's order it. So the x cubed term goes first, 2x cubed. And now we're looking for an x squared term, which is right here. And then we get our x term, minus x. And lastly, our constant, plus 7. And then that is divided by, we need to order the divisor also. So the x term should come first, -2x, and then the plus 1. Okay, so now that these are both ordered, we're ready to go ahead and set up the long division. So let's put up our division right over here. We'll leave a little bit of space for our divisor and we'll draw the long division diagram. So our divisor, which we put first, that's negative 2x plus 1. And then we've got our dividend, which is 2x cubed minus 11x squared minus x plus 7. We put that on the inside. And we're ready to go ahead and get started with our long division process. So first question, we're going to be looking at the leading terms of the divisor and the dividend. We're going to look at the highest degree terms, and those are just our negative 2x here and our 2x cubed. And we ask, how many times does the highest degree term of the divisor go into the highest degree term of the dividend? And we can figure that out by dividing the terms. So 2x cubed divided by negative 2x, and the result when we do that division is just negative x squared. So our negative x squared will go up here, negative x squared. We'll put that in the x squared column, and then we need to figure out what is our divisor times negative x squared. So negative 2x plus 1 times negative x squared makes, well here, negative x squared times negative 2x, the negatives cancel and we just got 2x cubed, and then negative x squared times 1, so 2x cubed minus x squared. We'll put that underneath here, 2x cubed minus x squared. So now we have to subtract that from the dividend and see what's left over and just keep on performing the process until we get to the end. So 2x cubed minus 2x cubed, that cancels. Negative 11x squared minus negative x squared, that's really negative 11x squared plus x squared, which is just 10x squared, or negative 10x squared, rather. And then we bring down the next term, the minus x. And we perform the same process again. So we take the leading degree term, that's negative 10x squared. How many times does negative 2x go into negative 10x squared? Well, we can find that by dividing negative 10x squared divided by negative 2x. That yields a result of 5x. So we put that up here, plus 5x. And then what do we get when we multiply our divisor by 5x? Well, we get negative 2x plus 1 times 5x, which is equal to negative 10x squared plus 5x. So we put that underneath here, negative 10x squared plus 5x, and we subtract that. Alright, so negative 10x squared minus negative 10x squared, that cancels. It should always happen, it should always cancel. And then negative x minus 5x, we get negative 6x. And lastly, we bring down the constant term. This is the last time we'll have to do the process. Bring down the plus 7 and look at the leading term here. That's negative 6x, and divide it by the leading term of the divisor over negative 2x. And our result is just 3. So we put that up here, plus 3 in the quotient, and then we have to multiply the divisor by 3. Negative 2x plus 1 times 3. That gives us a result of negative 6x plus 3. And we'll put that below here. Negative 6x plus 3. Subtract that. Negative 6x minus negative 6x. That's negative 6x plus 6x, so that cancels. Good. That means we chose the 3 was correct. And then 7 minus 3 is 4. And now, since the degree of our remaining part here is less than the degree of our divisor, that's our remainder. So remainder is 4. So now we're pretty much done. Let's just write our main finding, our main takeaway here. Our main takeaway is that our fraction, our division problem, 2x cubed minus 11x squared minus x plus 7, when we divide that by negative 2x plus 1, our result is that we get our quotient, which was up here. That's our negative x squared plus 5x plus 3, plus our remainder, so plus 4, divided by our divisor, negative 2x plus 1. So there is our main takeaway of our long division. Like before, we could check our answer by multiplying both sides by -2x plus 1. We won't actually do the multiplication because it'll take a little bit of time to perform, but if you did, you should find that this right-hand side, when you multiply it all out and simplify, that it should come out to the original dividend on the left-hand side, this 2x cubed minus 11x squared minus x plus 7. If it comes out to that, you know you're right. If it doesn't, you know you made a mistake somewhere in your long division. In the future, we'll also learn how to perform polynomial long division with higher degree denominators. Here we just had a first degree denominator, a linear denominator, but in the future we'll also consider quadratic or cubic or even higher power denominators. And we'll also see a faster way to do polynomial division in the case of the linear denominator, which is known as synthetic division.